Okay, so welcome to this new update on my dome automation project. Quite a lot has gone on since the last video I posted. I've made a lot of progress, had a few setbacks, but have pretty much conquered all the issues. One of the things I mentioned earlier was it's all related to the actual project, is I've actually got around to putting this aluminium skirt up here on the dome. This was to solve the issue I was having with friction caused by this material, which used to go all the way around the dome and used to shrink when it got cold and actually cause a lot of friction. Now this aluminium is on the outside and it actually clears the dome all the way around, so you get a good, I can't move it because the motor's on there, but it moves very easily and the motor can turn the dome under all conditions. So that's the major thing that's gone on the outside. Bit of new paint which looks nice. I'm about to paint this as well, so it's all going to look very nice, as well as with the motorization completed. So let me show you what's been going on inside and give you a quick demonstration. So here we are inside the dome again, and an update on the hardware side of things. Firstly, you can see the little mirrors now go all the way around the dome. These are 32 of the little stick-on bathroom tile mirrors that are used by the infrared detectors, which we'll have another look at in a minute. The motor here with a much nicer rubber cord on it that's giving the tension, keeping the wheel up under the metal ring, and it means the ring will ride out the wheel will ride out the inaccuracies of the ring. So also the control box is now neatly screwed on the wall, and the little box that I've shown before, the interface box to the infrared detectors, is now nicely on the wall. So it's easy to plug in. I haven't finalised the routing of the wire because, a bit early days yet, but I will make that look a bit neater. And the other big addition is this Heath Robinson looking bracket here has got a little reed switch on the back, a magnetic reed switch. It's a little glass thing, it's very hard to see probably, but it's quite delicate actually, and it's used in conjunction with these magnets here. When these magnets are detected by the reed switch, then that is the home position, and that means that the dome is positioned due south. So I've arranged for that. So and that plugs into this little 9-way connector, which is a new thing since I last showed the system. And I'm just going to whip the lid off and just remind yourself what it looks like inside. This is the main control box for those that haven't seen the previous videos. In here we have the 24-volt power supply. We have the 24 to 5 volt supply for the Raspberry Pi, which is the main dome control computer. We have the little H-bridge controller for powering the 24-volt motor, and just a few other resistors and a bit of wiring for the various inputs that are coming in from these connectors to detect the the position of the dome and also the home. Okay, so I'll just put the lid on and then I'll give you a demo. So just a brief demo of some of the features that are actually working. As some of you have seen before, I've got a Python program here running on my observatory laptop. And this window here, let me just get rid of that for a second. This window here is just a VNC window into the Raspberry Pi, which is running another Python program that controls the various bits of hardware. And these two programs talk via sockets, and I've got them connected at the moment. And so, for example, at the moment I can do things like homing the dome. So at the moment we're actually, it says the dome is currently at marker 5, and it gives the azimuth. So it's not on marker 0, which is home. So if I click the home button, the dome will now slew, and it knows which way to go, it knows where it is, and it's now moved to the home position with the reed switch is now, the magnets are now opposite the reed switch. So that is the home position. what I can now do here is give you a demo of the fact that I can communicate with the ASCOM driver of the mount. So I'm connected to the mount, and this is the ASCOM driver of the mount. At the moment, the mount is in its counterweight down parked position. And so, for example, I can actually slew it from here. So I'll actually tell it to go to, an altitude of 45 degrees and move it a few degrees around. What I would normally do, of course, is I would slew the telescope using my observatory software, but just for these purposes, I'm just going to do it from here. So if I hit slew, the telescope is now slewing. You're pretending now that I'm about to image a galaxy, and the telescope is being controlled by Sequence Generator Pro, and it's now slewing, doing its stuff. Okay, so the telescope will move, and it's nearly there. I got it to move so that it's 45 degrees in azimuth around, and at 45 degrees altitude. So there we go, nearly finished. Okay. So the telescope has finished slewing, and now I can, let's pretend I didn't tell it where to go. I can now read the mount, and it refreshes the knowledge of where the mount is in right ascension and declination. And now I can say to the dome, move to the target. So if I click that, the dome is now making its best effort at positioning itself so that the telescope is in the centre. And it's close. Now, one of the things I've still got to do is that there's a lot of complicated geometry to take into account the various offsets of the telescope from the centre of the dome. And I've got a little bit more work to do to get the trigonometry right, but at the moment it's getting very close. And what I would do now is I would, and this is how I want it to work at the moment. I would say, well, it needs to come forward a couple of markers, a couple of sort of ticks, if you like, on the dome. So I could just say here, send command, I'll say move 3 markers forward, I send the command, and there we go, it's moving 3 more little ticks, and I can check the position of the dome, and that's lovely. And that would be where I'd want it to start tracking. Now, all I have to do now is just hit the start tracking button, and it says tracking 541 seconds until the next move. And what it's now doing is it's calculating what the azimuth of the star is, or will be, in 5 minutes time, and it's then working out the rate of movement, and the dome will then nudge along in 500 odd seconds from now, which is a bit under, what's that, 9 minutes or 8 and a bit minutes. So that's those are the features now going, and really it's doing everything I needed to do for this kind of imaging, where I just make sure that it's exactly in the right position and then tell it to track from there. And once I've solved some of the more complicated trigonometry, then the actual slewing will be more accurate, and I'll probably be able to fully automate the whole thing. But well, that's where I am at the moment. So I'll just stop the tracking and send the dome back to home. As you can see, it's going home in the reverse direction because it knows that that is the shortest distance. And now we're back home again, and that's it. That's the demo. So it'll be a little while now before I come up with another video. There's quite a little bit more programming to do to get the extra little features out, but that's pretty much where I am for the moment. So thanks for listening. Just thought I'd mention another little innovation is this little Yi dome camera, 1080p. It's actually called a dome camera because of its dome shape, so I thought it was very appropriate. It's very sensitive in low light. I can see the telescope. It's got infrared as well, so I can see the telescope in the pitch dark, see everything that's going on with the movement of the dome. That has been an absolute godsend for developing away from the dome back in my office, and having the confidence that the dome is not spinning uncontrollably away. So anyway, that I thought I'd mention, and I'd thoroughly recommend that.